we're going to solve systems of equations with 3 variables. So the idea is the same as when you solve it with 2 variables. It's just you can only do 2 variables at a time. So to keep things organized, I'm going to name each equation A, B, and C. And what you do is you pick 2 equations at a time. So the next step is going to have to be done twice. You pick 2 equations, and then in the next time you pick 2 equations again, but you have to pick the 3rd equation that you missed. So if you're going to do A and B, then you're going to have to do C and then one of the others again. You have to eliminate the same variable when you do them. So if you eliminate all of the Z's, then the next time you have to eliminate all of the Z's again, because the object of this step is to shrink it down to 2 equations with just 2 variables. So when you eliminate the same variable, then you only have 2 different ones. So you try to pick the easiest thing to do. In this case, any of them would have been okay. If we had eliminated the Z's, our coefficients are 1, 3, and 5. So because of the 1, it makes it super easy. We would have just used the 1 both times. Same thing with if we had eliminated y. And also same thing since we did eliminate x here with the 1, 2, and 2. Then first I take equation A and equation B, which have coefficients of 1 and 2 in front of the x. And so they need to be the same or the same but opposite signs. And so in this case, we need them to both be 2, so we did 2a and b. We took the entire top equation times 2. That's what makes it okay. We multiplied the left side by 2 and the right side by 2. So look at the top equation, and I doubled it, and then I wrote the middle equation. And then here, we're looking at 2x and 2x. They're the same, so we will subtract the whole equation. And then for organizational purposes, I put a little star next to it, because later when I'm looking for what I need, the star will catch my attention and I can get to it faster. So then on the next step, I'm going to eliminate one variable again. This time I have to use equation C, and because it has the same x coefficient, I'm also going to use b. So we're going to use b and c, and then because they're both the same, I'm going to subtract the equations again. And then I also put a star at the end of this equation, and so then after this I'm going to use the 2 starred equations for my next step. So the goal is to get one variable eliminated, and then now we'll have a system of 2 equations and 2 variables, and then we use substitution or elimination to solve those, just like we have been. You'll notice you have an issue at this point if you did not eliminate the same variable both times. And also, even when you do eliminate the same variable, sometimes you get some crazy coefficients, and all you're going to have to do is just multiply both equations, and you might get big, difficult numbers. It just depends with whatever your problem happens to be. Sometimes which variable you happened to eliminate. With my 2 starred equations, I've got y's with coefficients of 5 and 2, and z's with coefficients of 1 and 8. So because of the 1, I'm going to eliminate the z next. It's 1 and 8, so I have to take that equation over there on the left times 8, and I have to do it to the whole equation. And now my coefficients are 8 and negative 8, so I can just add the 2 equations, and then that will let me solve for y. So at this point, most of the really difficult stuff is done. Now we have the starred equation where we know one of the variables, so we're going to substitute that in there and solve for the other unknown variable. And then once we have 2 of them, we put those back into one of the original ones to calculate the 3rd. And when you're done, you write your answer as an ordered triple. For this next example, I eliminated the y's because two of them have a 1 for a coefficient. You really only need 1 to have 1, but just in general, you try to go with the easiest coefficients overall. So if there's not a 1, then try to get one of the variables that has a coefficient that's a multiple of one of the other coefficients. So we're going to eliminate y here. They have the same but opposite coefficients, so that's why we add these two equations. And since we have to add the y, to eliminate them, we have to add the whole equation. Now, since we didn't use b last time, we have to use it this time. In this case, I'm using 4a and b because that will give me the same but opposite coefficients for the y's. And since they are the same but opposite, we add them again. This time, the coefficients for x are 7 and 9, and the coefficients for z are 2 and 10. And because 10 is a multiple of 2, it's easier to eliminate the z's. All we have to do is take that equation over there on the left times 5. And since they'll have the same coefficient, this time we subtract the equations. Once you have solved one of the variables, most of the really difficult work is done. You take that answer and you plug it into one of the starred equations to solve for the second answer, and then you take those two answers and plug it into one of the original equations to find all three answers. Write your answer as an ordered triple.